nested brackets. So let's get right into it. So we're going to start with collecting of like terms. What does it mean by to collect like terms? In every algebraic expression, when we have one or two, three or more terms that are alike in nature, we tend to collect them. Those terms are called like terms. For example, if I have 3xy plus 2x minus 3xy plus 4xy minus 7x plus 4. If I want to collect like terms from here, this particular expression, first of all, I'm going to look at the variables. What are variables? Variables are x, y, all the alphabets you have that can be defined and can also be redefined. So look at this expression. We have for this particular term, this is called the first term, this is called the second term, this is called the third term, this is called the fourth term, and this is called fifth, and this is called the sixth term. So we look at the first term, we look at the variable there. The variable there is x and y. So we look at through the other terms, we look through the other terms and check for any other variable that looks like this, that is x, y, 2. And as we can see, we have 3xy, we have xy here, we have xy here, and we have xy here. So we can collect that. So we can collect that by saying 3xy minus 3xy plus 4xy. So if we check again, the next term there is 2x. So we tend to look for, is there any other term that has x? So this is 2x and this is minus 7x. So both of them are like, so we collect them. So that will give me 2x minus 7x. This is just a constant plus 4. So we carry out any other operation, any other arithmetic operation we have. So this is 3xy minus 3xy, that will vanish. So this is 4xy, that is 4xy. So this is 2x minus 7x, that will give me minus 5x plus 4. So we are left with 4xy minus 5x plus 4. So let's look at other questions that has to do with collecting of like terms for more understanding. So if I say I have minus 4l plus lxy plus 7lxl minus mn plus 3lxy. So, and I'm asked to collect the like terms in this particular algebraic expression. So we are going to say solution. So let's solve this. So we have minus 4xl. So if we tend to collect like terms, this is minus 4xl. What other term has xl? That is this term. This is xl. This one has xl, but it also has y, so they are not alike. So we are going to collect those two, and if we do that, we have minus 4xl plus 7xl. So we're going to check again which other term looks alike in this particular concept. So if you look, we see that we have lxl. So lxl, this is lxl. Which other term has lxl? This is lxl. So we tend to add those two together. So if we do that, we are going to have, this is plus lxl plus 3lxl. So the only thing remaining is minus mn. So we can now carry out the operation. So this is minus 4xl plus 7xl. That will give me 3xl. This is lxm plus 3lxm. That will give me plus 4x lxy. So this is lxy plus 3lxy. That will give me 4lxy minus m. Another question there for us to solve. So let us look at 3 arrow st minus 4 arrow tr str plus 8tx minus 5 arrow t plus 2xt. So let's solve this and call it the last one for this. So you can actually pause this video and solve this for yourself. So let's look at this. We have 3 arrow st, 4 tr. So these are alike. Is there another value that has xtr, or we don't have? So we just bring it together. Arrow 3 arrow st minus 4 str. This is 8tx. Is there another value that has t and x? Yes, there's a value here that has t and x. So this plus 8tx plus 2xt minus what? 5 rt. This one is just alone. So this will give me 3 rst minus 4 str will give me minus rst. 8tx plus 2xt will give me plus 10st, or you say plus 10tx minus what? 5 rt. So this is the answer. That is collecting, or just what we are doing here is just collecting like this. So the question can come in this way: say collect the like term in the following, collect like terms in the following algebraic expression, collect like terms. So that is that. So the next thing we are going to look at is called expanding of brackets. So we are going to look at expanding of brackets. Expanding, or you can also call it opening of brackets. So expanding of brackets. So let's look at expanding of bracket. Now, there are algebraic expressions that are of this form: xl minus x minus y. You can also have 4 over 3 x r divided by rot minus t minus 1. You can also have 2 over 3x divided by x plus 1. So all these are algebraic expression with the use of brackets. So question can come and say you should remove this bracket, you should expand the following algebraic expression. So how can we get rid of those brackets? So it is very simple. So let me solve the first one. The first one is 3x into x minus y. This is actually looking up to distributive rule of algebraic expression. It looks like that. So this is 3x multiplied by x, that will give me 3x squared. 3x multiplied by minus y will give me minus 3xy, and that is the answer. You can see the bracket is off. So let's look at for this one. This one is 4 divided by 3x r into rt minus t minus 1. So we just multiply in. 4 over 3x r multiplied by r square will give me 4 over 3x r cube minus what? 4 over 3x r multiplied by minus t will give me 4 over 3x r t. Then this minus 1 will just retain it as minus 1. So this is also the answer. Then for this one, I would have loved you to do this one yourself. So you can actually pause the video and do this one yourself. But let me do it for you. So this is 2 divided by 3 r into x plus 1. I will drop exercises below this video. You will see some exercises, you can actually practice and put the answer for me in the comment section. We are going to discuss on it. So this is 2 divided by 3 r multiplied by x. This will give me 2 divided by 3 r x. 2 divided by r multiplied by 1 will give me plus 2 over 3 r. So this is actually the answer for that one. So let's go to the next. Xy minus what? 13xz. Let's look at the second one. The second one is 3rxt minus 4xtr plus x8tx. You can actually pause this video and try it out yourself. Plus 2xt. Solution. So if you look at this, this is x arrow st, this is xt arrow, they are all alike. These two are alike. So I'm going to take that. So 3 arrow st minus 4 st arrow. This is tx and this is xt. They are alike. So I take plus 8tx plus 2xt minus 5 arrow t. So this is 3 minus 4. That will give me minus arrow xt. This is 8tx plus 2xt. That will give me plus 10tx or xt, as the case may be. And this is minus what? 5 arrow xt, 5 arrow t rather. So this is equal to, is there anything alike for me to take here? No. So I'm just left with minus arrow st plus 10tx minus 5 arrow t. So that is the answer. So the next thing we are going to look at here is called powers and logarithms. Okay, before I go into powers and logarithms, let's look at expanding bracket. Is there, like you call it expanding of bracket or opening of bracket? Expanding bracket. I hope that is the spelling of brackets. Yes. Expanding bracket. What is expanding bracket in algebraic expression? It is the process of removing all the brackets in any algebraic expression. Let us take, for instance, I have something of this nature. 3x into y minus 2z. And I'm being asked to expand or remove brackets. The question I'm just going to say expand. How do I accomplish this? It is just for me to distribute this 3x into this bracket. How do I do that? This is 3x multiplied by y. That will give me 3xy minus. This is 3x multiplied by minus 2z. That will give me what? Minus 6xz. So that is the answer. So let us look at more questions. So the questions here say expand the following. So the first one we're going to expand is minus 2y into 2x minus 4z. I'm going to solve just 2. And then the second one we're going to look at is 2xy minus 2 into x plus y. Solution. Let me share this board into 2. So now let's go down. So the first one is minus 2y into 2x minus 4z. Minus 2y multiplied by 2x will give me minus 4yx. Minus 2y multiplied by minus 4z will give me plus 8 plus 8yz. So this is equal to minus 4yx plus 8yz. That is the answer. The bracket is being removed. The second one, says 2xy minus 2 multiplied by x plus y. 2xy multiplied by x. Okay, let me do this in the next. So we have 2xy minus 2 multiplied by x plus y. So all I'm going to do is distribute. I'm going to distribute 2xy into the second bracket and then distribute minus 2 again into the second bracket. What do I mean by that? I mean 2xy I distribute into the first bracket, the second bracket rather, x plus y. Then minus 2 I distribute into the second bracket, x plus y. 2xy multiplied by x will give me 2x square y. 2xy multiplied by y will give me 2xy square. Minus 2 multiplied by x will give me 2x. Minus 2 multiplied by y will give me minus 2y. Do we have like terms? Yes. 2x, okay. Do we have like terms here? This is x square y. This is xy square. No. So this is the answer. So that is for this. So we are going into what is called powers. Okay. There's another form of bracket I'm going to talk about in this video, and that is called the nested bracket. So what is the nested bracket? It is usually not common. It is usually not common, but in most exams, some exams, you're going to see expanding of nested brackets. So first of all, how do you identify that an algebraic expression is in a nested bracket? You first of all understand what a nested bracket is. Whenever an algebraic expression contains brackets in other brackets, it is said to be in a nested bracket. Whenever an algebraic expression contains other brackets inside other bracket, that is, I have multiple brackets inside a bracket, it is said to be a nested bracket. And the only way you can be able to remove such bracket is by expanding the innermost bracket first. What do I mean? If I have an algebraic expression of this form, 7 into a minus this bracket 4 minus 5 into b minus 3a bracket close. So if you look at this algebraic expression, you can see that we have an innermost bracket and then we have this outer bracket. So I consider this to be that we have two brackets in this expression. So this is called a nested bracket. So for me to be able to expand this kind of algebraic expression, I have to first of all deal with the innermost bracket, which is this one, which is 6 minus 3a. After dealing with this innermost bracket, I deal with the next innermost bracket and then before the outermost bracket. So how do I expand this? First of all, we remove the innermost bracket, which is this. So for me to remove the innermost bracket, we say 7 into a minus 4. Now I'm removing the innermost bracket, which is 6 multiplied by 6 minus 3a. So that is 4 minus. So let me remove this innermost. This is the innermost bracket here. So that is minus 5 multiplied by 6 will give me minus 30. Minus 5 multiplied by minus 3a will give me plus 15 what? A. Bracket close. So the next bracket I'm going to deal with here is also the bracket that is also inner. And that bracket there is this one. So I'm going to deal with this bracket here. So now for me to remove this bracket is very simple. So I continue for where I stopped. So this is 7 into a minus. So there's nothing. So a minus multiplied by 4 will give me minus 4. Minus multiplied by minus 30 will give me plus 30. Minus multiplied by plus 15a will give me minus what? 15a. Now I'm left with just one bracket, which I can deal with easily. That is 7 multiplied by a will give me 7a. 7 multiplied by minus 4. 7 multiplied by 2 is 14, 28. That is 28. Plus 7 multiplied by 30 will give me 210, if I'm not mistaken. 7 multiplied by 15, that is 15 multiplied by 7. 7 times 5 is 35. 7 times 1 is 7 plus 3, that is 10. 105, if I'm not mistaken. 105a. So is there any like term? Yes, these are just like terms here. These are the like terms here. They are just constants. And this is also a like term. So we can collect like terms. This is 7a minus 105a. 105a minus 28 plus 210. So let's go. So this is 7a minus 105a will give me minus 97. Okay, 98a will give me 98a. Then minus 28 plus 210 will give me plus 10 is off 18 in 200. That is about 182. 182. So that will give me minus 98a plus 182. You can actually check this with your calculator and confirm. So this is the answer. So I just want to give a brief explanation of this because I'm going to solve just one more question on this. So now, this is a nested bracket. How do you identify a nested bracket? I said for you to identify a nested bracket, it is an algebraic expression that has lots of brackets. That is another simple way to say it. That has brackets inside of brackets. So now it's just saying we have this first bracket, as you can see, we have the second bracket here, as you can see, and then we have the third bracket. Now, for you to be able to remove this kind of bracket, you have to first of all deal with the innermost bracket. The innermost bracket here is the bracket inner, which is this one. This one that has 6 minus 3a. So I first of all get rid of it, and every other thing remains the same. So that is 7 into a minus into 4. Minus 5 times 6 will give me minus 30. Minus 5 times minus 3a will give me plus 15a. So this is equal to 7 into a minus 4 plus 30 minus 15a. So this is equal to 7a minus 28 plus 210 minus 108. I take like terms to have 7a minus 105 minus 28 plus 210. That will give me minus 98a plus 182. So let's look at the next example. So let's look at another example. Okay, let's look at 3a into a minus 3 minus 4 minus x. So this is another one. Okay, let me say 4 minus this. This is example 2. So solution. So we accept that we first of all deal with the innermost bracket. So everything remains the same. 4 minus 3a into a minus 3 minus, now minus times 4, we open that innermost bracket, minus 4. Minus times minus x will give me plus x. So now we deal with this other bracket here. Everything remains the same. We have 4 minus 3a into a minus 3. Minus times 3 will give me minus 3. Minus times minus 4 will give me plus 4. Minus times plus x will give me minus what? X. So we deal with this other one. That is 4 minus 3a squared plus 6a minus 12a plus 3ax. Is there any like term for us? Yes, there are like terms. This is a and this is a. So we take that to say this is 4 minus 3a squared. 6a minus 12a will give me minus 6a plus 3ax. This is the answer. So let's move on. So the next thing we are going to look at here is powers. You can either call it powers, you can call it indices, or you say exponents. They all mean the same thing in algebra. So that's what we are going to look at here. So let me motivate this. The use of powers, you say indices or exponents, produce a convenient form of algebra expression in shorthand. The use of powers or indices provides a convenient form of algebraic expression in shorthand. What do we mean by that? If I cannot just write an algebraic expression, say, okay, for example, say p times p times p times p. In shorthand, this can be written as p raised to power 4. That is 1, 2, 3, 4 p raised to power. So instead of writing this, we write this. So this guy here is called the power, or you say the index. Why this guy here is called the base. So if I have something of this form, say 4p5, this is called the power, this is called the base, and this is called the coefficient, as you can see. So the use of powers provides a convenient form of algebraic expression in shorthand. So if we have 4p raised to power 5, this is called the power, this is called the base, and this is called the what? The coefficient. So let us look at some rules. Let's look at some rules. So let us say rules of indices or rules of powers. But it is better to call indices. Rules of what? Indices. So it is index. Power is also the same thing as index. It's also the same thing as exponent. But when it's more than one, we call it indices for plural. So the first rule states that a raised to power m, that is multiplication rule, multiplied by a raised to power n is equal to a raised to power m plus n. This is multiplication rule. This is for multiplication. So when you have two base, same base, and different powers, all you have to do is to retain the base and then add up the power. For example, if I have a raised to power 5 times a raised to power 6, this is equal to a raised to power 5 plus 6, which is equal to a raised to power 11. Rule number 2 for division. A raised to power m divided by a raised to power n is equal to a raised to power m minus n. So when it's division, we subtract the power. So that's as simple as saying a raised to power 5 divided by a raised to power 6 is equal to retain. So far we have the same base. We retain the base and we say 5 minus 6, which is equal to a raised to power minus 1. The next one is what we call the zero power, or let me say the product. Let me first of all talk about the products. So if I have a raised to power m raised to power n, this is equal to a raised to power m times n, which is equal to a raised to power mn. So if I have a raised to power 5 raised to power 6, this is equal to a raised to power 5 times 6, which is equal to a raised to power what? 30. The fourth one, if I have a raised to power 0, already we know in mathematics any number raised to power 0 is equal to 1. This is because a raised to power m divided by a raised to power n is equal to a raised to power m minus n, which is the same thing as saying a raised to power m divided by a raised to power n. And if m is equal to n, then a raised to power m minus m is equal to a raised to power 0. And from here, this is the same thing as saying a raised to power m minus m is equal to a raised to power m divided by a raised to power m. This is equal to 1, we know. If we cancel that, this will give us what? 1. So a raised to power 0 is equal to 1. let's look at the next one. The next one, that is rule number 5. A raised to power minus m, we have a negative power. It's the same thing as 1 divided by a raised to power m. This is because a raised to power minus m is equal to a raised to power minus m multiplied by, this is m, a raised to power m divided by a raised to power m. This m and this m can actually cancel out and just give us what is here already. So this is the same thing as saying a raised to power minus m plus m divided by a raised to power m, which is equal to a raised to power 0, because minus m plus m will give us 0, divided by what? A raised to power m. And we know a raised to power 0 is 1 divided by what? A raised to power n. Proved. The next rule is this one, is the rule that has a fraction at the power. So a raised to power 1 over m is equal to the n root of a. And this is because a raised to power 1 divided by m, if I multiply by m, this will give me a raised to power m divided by m, because if I do this, 1 over m multiplied by m will give me this, and this is equals to a raised to power 1, and this is equals to a. So a raised to power 1 divided by m is equal to what? M root of a. Then from this we can also agree that a raised to power n divided by m is equals to a raised to power 1 over m raised to power n, which is equal to m root of a raised to power n, which is also equal to m root of a raised to power n. So this is equal to this. So these are the basic rules of indices. So let's look at an example.